Hi guys, hello everyone. How are you? Uh, Let us see the continuation of equilibrium PYQs, JEE advanced PYQs. We are going through that. Uh, Two questions we have already gone through that in previous videos. Now in this video we are going through the third one and fourth two questions. Both are very similar. The first one in 2001 screening they have given that JEE advanced screening test, and one more is 2002 screening they have given. Okay, these two questions we can see, and these two questions are similar. Let us go through that, how to find out. You can see here, we know the relation for the solution of this. At constant temperature Kp for the reaction, decompose, actually this reaction is decomposition reaction. N2O4 gives rise to 2NO2, okay, and Kp is given as 4x square P by 1 minus x square. They are expressed in terms of Kp, and how it will be, P is the total pressure and x is the degree of decomposition is given, okay. Let us go through here. Here they have given x, that's why we are going through the derivation of the part of the derivation. Let us go through this. You can see Kp is equal to, from the equation what we can write, the partial pressure of NO2 products by reactant, equilibrium constant what we can write here, product by reactant, Kp is equal to partial pressure of NO2 first we have to write, then after partial pressure of N2O4, Pn2O4 you have to write like this, okay. But we know that very well from the equation. Here it is given equation what we can write, you can write it as, I am writing the step, N2O4 gives 2NO2. See, initially what, 1 mole and 0 before decomposition, keep that in mind. Before decomposition it is initially 1 mole and the product does not formed, we can say that it does not formed, therefore it is 0. After some time 1 minus x, that means from 1 mole how much amount is decomposed, x amount. That means for example you consider here from 1 mole 0.1 mole or 0.2 mole or 0.3 mole, like that some x amount of here it is decomposed, that is called a degree of decomposition, we call it as, okay. And how much it appears, 2x, okay. And these are number of moles which is decomposed, number of moles which is here formed, we can say that. Therefore it can be written as what, the total number of moles, total number of moles, how much, total number of moles equal to 1 minus x plus 2x, we can write it here, that equal to what, 1 plus x. And partial pressure of NO2 according to what, Dalton's law of partial pressures, PNO2 is equal to XNO2 into total pressure P, we can say that, okay. PNO2 is partial pressure, P means here whatever we are looking at, this is which pressure, total pressure, you consider here total pressure, and x into P according to Dalton's law. X equal to means what here, x is called here mole fraction, keep that in mind all of you. X is mole fraction here, the mole fraction of NO2 in the mixture of gaseous mixture, we can say here. Therefore you consider that it can be written as number of moles at equilibrium. How many moles for NO2, number of moles at equilibrium, 2x. Therefore it can be written as 2x. The total number of moles how much, 1 plus x. 2x by 1 plus x, into total pressure P, we can write like this. This is the expression for partial pressure, x into P. P indicates total pressure, keep that in mind. PNO2 means partial pressure of NO2, okay. Yes, and the next one here what we can say, and one more here, I am going to continue here. The continuation of this video, you can see it is the question will be belongs to both the same expression and same equation we can consider here. That's why I am extending here for the fourth question also. These two are similar questions. You keep that in mind, all of you. Right now, P into O4, partial pressure of N2O4 is equal to mole fraction of N2O4, into total pressure. Mole fraction of N2O4 how much? The number of moles at equilibrium by total number of moles. That means what we can write here? 1 minus x by 1 plus x into P. We can write 1 minus x of N2O4 at equilibrium. Number of moles of N2O4 at equilibrium. This is the condition initially. Here it is. Condition is initial and and at equilibrium. This condition is at equilibrium. Keep that in mind, all of you. Right? Therefore, now take these partial pressures and substitute in this equation. When we substitute in this equation, I am rewriting that here. You see, Kp is equal to partial pressure of N2 equal to what? 2x by 1 plus x into P. Okay, 2x by 1 plus x whole square into P square. We can say that because total we have to make it square. That's why the total term we have to make it square because square is there. P and 2 over how many moles? 2 moles. Therefore, we have to make it square. That's why I have written in that manner. And the denominator term what is there? N2O4. That means 1 minus x by 1 plus x into P. That we have to substitute here. I am writing the denominator term here 1 by Pn2O4 1 minus x into what denominator of denominator into P is there and the denominator of denominator becomes what? Numerator. Keep that in mind, all of you. 1 minus x by 1 plus x, we can write it here. Okay, denominator of denominator it becomes numerator, and here 1 plus x, 1 plus x, one of the 1 plus x is cancelled out and one more is remaining, and p square and p cancelled out. Therefore, I am rewriting here 4x square by 1 only square, one of the part of the 1 plus x has been cancelled, one more 1 plus x is remains same. Keep that in mind, all of you. Right? Into 1 by 1 minus x into P. 1 P's remain same, I am writing separately. Okay, we are deriving this expression. Okay, we will go through that. Now, for understanding purpose, because here it is not given, it is given directly expression. That's why I am explaining once again how to find out the Kp, expression for Kp. Therefore, keep that in mind. Now, 4x square into P, 1 minus x square, finally we got it, right? And once again I have derived the same equation. Instead of x, what is here in this case? Alpha is here. Alpha is also same. Alpha is considered in this question degree of dissociation. Here the notation is given as x here, notation is given as alpha here. Both are same, keep that in mind. Okay, right. I am rewriting the equation Kp is equal to, this equation again I am writing Kp is equal to 4x square into P by 1. See, a plus b into a minus b becomes what here? A square minus b square. Therefore, we can write like this 1 minus x square. We got it here. See, now actually the question asked from this expression, what they are asking, Kp increases with increase in P. They have given. Kp increases with increase of P. They have given. Is that so? Actually, we know that Kp and Kc, Kp in equilibrium constant in terms of pressure, and Kc also we know that very well, equilibrium constant in terms of concentration. Kp and Kc are always constant. Always constant. They depend only on temperature. But here the condition is given is what? At constant temperature they have mentioned very clearly. In both the questions they have mentioned very clearly at constant temperature. Therefore, here it depends only on temperature. Kp and Kc equilibrium constants. These are equilibrium constant in terms of pressure, equilibrium constant in terms of concentration. They are always constant except what? Temperature. Only they depend on temperature. Okay, we have to consider that. Okay, keep that in mind. Therefore, and one more thing here we have to keep it in mind. Since the temperature is constant, therefore here Kp does not change. Kp increases, they have given with increase of pressure. It's wrong, not correct. And the second option is given here. Kp increases with increase of x. Kp never change, therefore it is also wrong. Kp increases with decrease of x, it is also wrong. Kp remains constant with change in P and x. Okay, the correct option is D. And how Kp remains constant with change in P and x? Let us go through that. Okay, I'll give you one more equation. I'll give you one more derivation here with respect to the question. Right. Now, for this question it is correct. Kp remains constant with the change in P and x. How the change in P and x, how it influences, that was given in this question. That it is, the question here it is, you see, same conditions, but here the extra condition is added in the fourth question. What is that? At constant temperature, the volume of the container is halved. Okay, it is in a closed container, it has been taken, the reaction mixture has been taken in closed container, the volume of the container is halved. When the container volume is halved, how the P and X will be changed? Pressure and degree of dissociation. Alpha is nothing but degree of dissociation only. Instead of X, what we can take here? Instead of X, you can take alpha also, no problem. Okay, because it's applicable for both the questions. Keep that in mind, all of you. Right. Now, neither Kp nor alpha changes. First option they have given, and let us check now. When the volume is halved, you can see that we know from the ideal gas equation, because both are gases. Both are gases. N2O4 and NO2 both are gases only. Let us consider total pressure P into V equal to nRT. You consider this, and pressure becomes what? N by V into RT. But condition is given what? Volume of the container is halved. That means V becomes what here it is? V by 2. N into V by 2 halved. Halved means becomes half. We can say that it becomes half. Keep that in mind, all of you. Okay. Therefore, when it becomes V by 2 into RT, it can be written as 2 into N by V, because denominator of denominator becomes numerator, N into RT into by V, we can say that. And here what actually happened, the volume, if it is halved, then the pressure increased by how many times? Actually here it is N by V into RT it should be, but when the volume is halved, then the pressure becomes doubled. Okay, because P is inversely proportional to V, we know that very well, at constant temperature according to Boyle's law. According to Boyle's law, at constant temperature what it is? At constant temperature, P is inversely proportional to V, Boyle's law, we know that very well. Understand? Yes. You keep that in mind. Therefore, here when the volume is halved, pressure becomes doubled. The pressure becomes doubled here 2 times of this. Okay, pressure is doubled. By looking at the equation, 2 times, it becomes 2 times of the original value. It is doubled. Pressure is doubled by the volume is halved. Okay, keep that in mind. Okay, right. Now the point is what? Neither Kp nor alpha changes they have given. Now, if the P is doubled, then Kp, what happens? Kp always constant. We said that when the pressure is changed, pressure has been doubled. But is it depends on pressure? No, it's not. Therefore, here we have to keep that in mind. The pressure if it is doubled, then Kp value is it changes? No. Neither Kp will not be changed. You can say that by change in pressure. Therefore, neither Kp nor alpha changes they have given. Kp never change, but alpha whether is it changes or not. Pressure is changing. We know that very well. But alpha pressure is changing. We know that here. Now, both Kp and alpha change. We can say both Kp and alpha changed. Obviously, it's wrong. Kp here there is a dilemma here. What is that? Neither Kp and nor alpha. Alpha whether it changes or not, we don't know that. Okay, let us go through now. Kp changes, but alpha does not. Kp changes. This is also wrong. Wherever there is Kp changes, then the statement is obviously wrong. Okay, obviously wrong. Why is it so? Because of constant temperature. If the temperature remains constant, Kp must be constant. It does not change. Therefore, B and C obviously wrong. And Kp does not change, but alpha changes. You see here, Kp does not change, but alpha changes. The point is here when we consider, Kp, neither Kp nor alpha changes they have given, but the value in order to make the constant Kp, which one has to be changed? Because here once P is Kp should be remain